welcome to True Projects. In this video, we will explain about Twitter sentiment analysis based on ordinal regression. Introduction. This project presents a sophisticated sentiment analysis technique for Twitter with 5 separate sentiment levels which are high positive, moderate positive, neutral, high negative and moderate negative. To forecast these sentiment levels, it employs ordinal regression machine learning methods and natural language processing techniques. Tweets are pre-processed and converted into bag-of-word representations and vectorized with term frequency inverse document frequency, which is TF-IDF. These vectors are then trained on publicly available Twitter datasets using aforementioned algorithms, offering a more detailed understanding of user opinions and sentiments on social media sites. This method goes beyond the usual binary sentiment analysis paradigm to provide a more in-depth understanding of user opinions and sentiments on social media sites. Coming to objective, the project's goal is to improve sentiment analysis in social media with a focus on Twitter by implementing more reliable sentiment classification system. Traditional techniques classify emotions as positive, negative or neutral. This initiative suggests 5 classification levels which are high positive, moderate positive, neutral, high negative and moderate negative. The goal is to forecast these complex sentiment levels using 4 ordinal machine learning methods which are softmax, decision tree, random forest and support vector machine. Natural language processing, which is NLP technique from the NLTK package, are also used in this project. It consists of pre-processing tweets, turning them into bag-of-word representations, and then vectorizing them into using TF-IDF calculations. These vectors are used and trained using the dataset from Twitter that are freely available to the public. This final emotion forecast is based on calculating polarity and comparing it to predetermined thresholds. These are the requirements needed for execution. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. In software requirements, Python IDE of 3.7 version is needed. These are the algorithms used in the project. First one is support vector regression. It is used to predict continuous values, making it well suited for ordinal regression tasks in this project. SVR is used to predict sentiment values that can be categorized into specific sentiment levels. SVR can capture complex relationships between input features and output values, enabling them model to predict sentiment levels based on the learned patterns in the data. Next one is random forest. It is an ensembling learning method that builds multiple decision trees and combines their output to improve accuracy and control overfitting. In the project, random forest is used to enhance the accuracy and robustness of sentiment prediction by aggregating predictions from multiple decision trees. This approach helps in mitigating the bias and errors that individual decision trees can produce. Last one is decision tree. Here it is used to divide dataset into subsets based on the values of input features. In the project, this decision tree algorithm is likely utilized for sentiment classification due to its ability to handle both categorical and continuous features. Decision trees can effectively learn the hierarchy of words' importance in determining different sentiment levels. It is used here to predict sentiment levels based on TF-IDF vector. Coming to methodology, we have designed these modules for execution of the project. First one is load NLTK tweets. Using this module, we will load Twitter sentiment corpora dataset from NLTK library. Next one is read NLTK tweets. Using this module, we will read tweets from NLTK and then clean tweets by removing special symbols, stop words and then perform stemming. Stemming means removing ing and tion from words. For example, organization word will become organized after applying stemming on each word. Then we will calculate TF-IDF vector. Third module is run SVR algorithm. In this module, we will give TF-IDF vector as an input to train SVR algorithm. This algorithm will take 80% vector of train and 20% vector as test. Then algorithm applies 80% train model on 20% test data to calculate prediction accuracy. Similarly, we will build random forest and decision tree to calculate their accuracy. In fifth module, which is detect sentiment type, using this module, we will upload test tweets and then application will apply train model on those test tweets to predict sentiments of that tweet. Sixth module is accuracy graph. Using this module, we will display accuracy graph between all the algorithms. For execution of the project, first open the code folder. This is the code folder of the project and this is the dataset folder. These are the negative tweets and these are the positive tweets. This is the trained tweets data. These are all the tweets. And on these tweets, we will build the algorithms. And this is the main code file. And this is the test tweets file, which contains the test data in it. And this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program, and this is created by using Tkinter library in the Python. So first click on the button Load NLTK dataset to load the data. Here, dataset is loaded, and now here tweets found in the dataset are 10,000. Now click on Read NLTK Tweets Data button to read all tweets and then build TF-IDF vector. Here, tweets are read and then they build the TF-IDF vector, and also it has split a dataset into train size and test size. In train we have 8,000 records, in test we have 2,000 records. All the algorithms, first they will train the model on 8,000 dataset and then they will test it on 2,000 dataset. So first click on the button SVR algorithm. Here we got the SVR accuracy. Now click on the button Run Random Forest algorithm. Here we got the classification report of the random forest algorithm. Here we have precision, recall, F1 score and support score of the random forest algorithm. And here we have the accuracy score of random forest. Now click on the button Run Decision Tree algorithm. Here we got the classification report of the random decision tree algorithm. Here we have precision, recall, F score and support values. And here we have accuracy score of decision tree algorithm. Now click on Detect Sentiment Type to test the data. Here we got the predictions. For this particular tweet, we predicted as high positive, and for this tweet it is predicted as neutral, and for this tweet it is predicted as high negative. Similarly, it has predicted all other tweets also. So now click on the button Accuracy Graph to view the all algorithms accuracy scores. Here on x-axis we have algorithm names, and on y-axis we have the accuracy scores of that particular algorithm. Among all the algorithms, decision tree accuracy is high. Close this GUI. Conclusion. The project tackles the shortcomings of standard sentiment analysis by offering a revolutionary technique to sentiment classification that divides sentiments into 5 levels, which are high positive, moderate positive, neutral, high negative and moderate negative. The project successfully predicts these complex sentiment levels for Twitter data using 4 ordinal regression machine learning algorithms and natural language processing approach. The use of TF-IDF vectorization and advanced algorithms such as decision tree improves accuracy even more. Decision tree emerges as a best accurate classifier after significant experimentation and analysis. The project contribution extends to sentiment analysis, providing a more complete knowledge of user sentiments on social media networks. The project creates better informed insights for users, companies, and product evaluations by supporting subtle emotion expression, consequently enriching the algorithm.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.